Nothing is unhackable, but by putting up barrier after barrier, you can turn yourself into such a frustrating target that most hackers will just give up and move on. The military took this multi-barrier concept and gave it a name, defense in depth, which simply means stacking multiple layers of protection until attackers give up out of frustration. That's why military bases have fences, gates, guards, guard dogs, and checkpoints. We see the same principle in finance. People protect their financial assets with LLCs, trusts, insurance policies, and offshore accounts, making lawsuits extremely difficult to pursue. Frustration is a powerful deterrent. So today, I'll show you how to stack so many barriers in front of SSH that hackers become demoralized and simply just give up. Let's start with the single most important barrier to hacking SSH, getting rid of passwords and switching to cryptographic keys, or SSH key pair login. If you remember nothing else from this video, remember this. SSH key pair login is far more secure than usernames and passwords. So to create a key pair, it takes two easy commands. We'll go ssh-keygen, and then it'll say, hey, where do you want to save this key? This is the default, so we'll go ahead and hit enter just to implement the default settings. And it'll say, do you want to enter a passphrase? Now, we don't have to enter a passphrase, but if we're really trying to keep SSH secure from hackers, hackers can steal your private key. This has been done in the past many times that corporations or organizations have been hacked. So one way to secure your private key is to give it a passphrase, which is essentially just a password for your private key. I am going to demonstrate adding a passphrase because it's more secure. So I will type in what I want for a passphrase and hit enter. It'll say, hey, can you please confirm that passphrase? So we'll type it again and hit enter. Now our key pair is generated. This is the private key. This is the public key. And now we need to copy over the public key to our SSH server. And we can do that from the client. We just go ssh-copy-id, and then we're going to save this login as the username vero at 192.168.229.128, and we'll hit enter. And it'll say here at the bottom, hey, what is Vero's password? We'll go ahead and type the password and hit enter. And now it says, cool, now you can try logging into the machine with your key pair. And so we'll do this, ssh vero at 192.168.229.128. Now notice the difference here. It's not asking for our password to log into the machine. It's saying, what is the passphrase for our private key? And that's really important to be aware of. It's asking, what is the passphrase for the private key? This way, again, if somebody steals our private key, it probably won't really matter because they won't have the passphrase for the private key. And if we make it a difficult enough passphrase, they're probably never going to be able to use that private key. So it doesn't even matter that they stole it. Just another barrier in the way of hackers. So I'm going to enter the passphrase. And there it is. It lets us in, just like that. Now I'm going to exit out of here because we don't need that connection for now. Again, if you want to know more about what I just did, you can go back to episode 3, which is passwordless login, and I go into a little bit more detail about creating and using key pairs. Now that we made our keys, it's time to install a deadbolt on the door that only our keys can unlock. This way no one can get in, no matter how many times they guess the password. Here's a little trick. We're about to change the SSH configuration and reload it. So I'm going to open a second SSH session and keep it open while we make these configuration changes. This way, if I make a configuration mistake and lock myself out, I still have one backup SSH session running that I can still get into the server with. Okay, so I'm going to open 2 sessions here. Vero at. We enter the passphrase that we set earlier, and we're in. And then I'm going to open a new tab. I'll zoom in so you guys can see. And then we'll type the same thing again. Enter our passphrase we set earlier. Okay, now I'm set. So now we are going to make some configuration changes for the SSH server. So we're going to open up a configuration file, sudo vi etc ssh sshd underscore configuration. Got to enter our password, and then I'll hit Shift G to go down to the bottom. I'll hit O to enter insert mode and go to the next line. And we are going to type the following. We're going to type password authentication no. And what this setting does is it says, hey, don't prompt for a password because we're not allowing password authentication. So that's what that does. Now we'll also do challenge response authentication. Uh-oh, did I? Yep, I misspelled something. Authentication. It lit up. That's how I could tell that it was spelled correctly. And we'll set this to no as well. And what this will do is it'll turn off any possible two-factor authentication or one-time code authentication services. So this way it forces SSH to use the key pair for login. And we're also going to explicitly set that. We'll type pubkey there I go, forgetting the N. Pubkey authentication, yes. Now, if we're turning off password authentication and any two-factor authentication, why are we explicitly setting pubkey authentication to yes? Well, different Linux versions behave differently. Sometimes this isn't set by default. So if we explicitly set it, we don't have to worry about whether or not it's set by default or what version of Linux we are on or any of that. So we just set it. And then we're going to type in one more. We're going to say use PAM. And then we're going to say yes. So PAM is pluggable authentication modules, and it handles some background processes for authentication. So a lot more than just SSH. It does sudo as well. It handles, when you type sudo, it handles that. So we explicitly set it to yes to avoid any sort of weirdness or any unwelcome surprises. Now that we've installed a deadbolt on the door, we're going to put up another barrier by creating and enforcing a VIP list, restricting not only what users can access SSH, but also where they can access it from, which IP address. And to do that, we're going to go back to our etc ssh-sshd underscore config. And that's this file I have open right here. And we are going to type these additional settings. We're going to type PermitRootLogin, and we're going to set that to no. And what that does is it just does not allow anyone to log in remotely over SSH directly to the root user. If you need to use root on the system, you first log in with your normal user and then type the sudo command from there. But this setting disallows anyone from logging directly in as root. And then the other setting we're going to input is we're going to restrict what usernames can log in. We're going to restrict it to either username John or username Vero. And then we're also going to explicitly set what IP addresses they can be coming from. Because if they're not coming from any of those IP addresses we specify, we're going to say don't let them in. So we'll type this. We'll type AllowUsers John at 192.168.229.0/24. This is a subnet. Unfortunately, networking and subnets are outside the scope of this video. So if you know what this is, then you know what it is. But essentially, for those who aren't familiar, this just says, hey, the first 3 octets of their IP address have to be this in order to let them in. And then we're also going to let in the username Vero with the same range of IP addresses, /24. So once again, anybody that's coming from these first 3 octets, and this is a wild card. This can be any valid number. Now that is set up, I'm going to hit escape, and I'm going to hold down shift and type ZZ to save and exit. Then we are going to reload the SSH configuration file into memory. So we're going to type sudo sshd -t, and what this does is this T stands for test. So it runs a test on the configuration file to see if we typed everything correctly, and if we did, it won't say anything, but if we mistyped something, it'll give us a message. And then we're going to type nn, and so what that does is it says, hey, if this command completes successfully, or go ahead and execute this next command as well. Sudo systemctl reload SSH. So if you don't know, systemctl is just a method we use to send commands to the SSH daemon. And then reload, notice we use reload instead of restart. That tells SSH to reread its configuration file into memory without restarting the SSH daemon. So we'll hit enter, and we got no error messages. So we typed everything correctly and everything reloaded correctly. So I'm going to do this. Now remember, I still have this session in the background as my backup. So I'm going to exit out of this session, and then I'm going to attempt to log in again. So I'll do ssh vero at 192.168.229.128. Says, what's the passphrase? Awesome. It lets me in. So we set everything up correctly. At this point, your SSH setup is no longer an easy target. You've removed passwords, you've enforced key pair login, you've blocked root logins, and you've restricted access by username and location even. Most hackers won't even get past the first layer, and the few that do will hit wall after wall until they likely just give up. If you have any questions about what you saw here today, drop them in the comments. And thanks for hanging out with me, and I'll see you in the next one.